This is meant to be a quick balancing reaction tutorial, so let's go over a basic reaction at first. Why don't we do something like Na plus Cl2 goes to NaCl. Okay. Now the first law of thermodynamics is that matter can never be created nor destroyed, only transferred from one form to the other. The transfer is indicated by the breaking of, in this case, ionic bonds, or formation of ionic bonds, or the breaking of covalent bonds, or the formation of covalent bonds. Chemical reaction. We would see color, gas, temperature change, change in smell, release of light, etc. if a chemical reaction happens. It can neither be created nor destroyed, meaning that the elements you start with are always going to be equal to the elements you end with in number, or molar ratio. So let's go ahead and balance this. I always start from the left and I move to the right. Every time I add a number, I start over. So I have 1 sodium here, I have 1 sodium here. Good to go. I have 2 chlorines here and I only have 1 here. So I can't put a number here, I can't put a number here, I have to put that number here. Now that I added a number, I'm going to start over. So I have 1 sodium here, and here I have 2. The 2 distributes through to the sodium and the chlorine. That means I have to put a 2 here. Now that I added a number, I'm going to start over again. Here I have 2 sodiums, and now I have 2 sodiums. Here I have 2 chlorines, and because this 2 distributes through, I have 2 chlorines. Good to go. I like to go through and put a 1 any place that's left. Let's move to a tiny bit more complex reaction. In this case, aluminum plus oxygen creates aluminum oxide. So, same thing. 1 Al here, 2 Als here, so I'm going to have to put a 2. Added a number, so I'm going to start over. 2 Als here, 2 Als there. 2 O's here, 3 O's here. Anytime you have 2 and 3, you can switch them. 3, 2, now I'm going to start over. 2 Als here. This distributes through, so I got 4 Als here. That means I'm going to go ahead and change that to 4. Let's start over. 4 Als here, 4 Als there. 6 O's here, and because I can distribute this through, 6 O's there. Good to go. Let's do one where the O's show up in different spaces. C3H8 plus O2 goes to CO2 plus H2O. This is a combustion reaction. So I'm going to go from left to right, starting with the carbons. 3 carbons here, 1 carbon here. That 2 only counts for the O. Common mistake. So I'm going to start over. 3 carbons here, 3 carbons here. 8 hydrogens here, only 2 there, so I'm going to put a 4 to get 8. Now I'm going to start over. 3 carbons here, 3 carbons here. Remember that 2 only counts for the O. 8 hydrogens here, and I got 8 hydrogens here. But as you see now, I have O's in 2 different places. When you see the O's, slow down. So here I have 3 times 2, that's 6 O's, and here I have 4 times 1, that's 4 O's, for a total of 10 O's. That means I need 10 O's over here. So I don't have any here, so I can just go ahead and put 5 there, because 5 times 10. So 3 C's, 3 C's, 8 H's, 8 H's, 10 O's, 6 plus 4, 10 O's. When you get to the O's, slow down. It's also common to say you have 3 on this side because you forget the coefficient. All right, now let's do a trickier one where you have an odd number. So let's take something like C2H6 plus O2 goes to CO2 plus H2O. So I'm going to start from left to right. 2 carbons, 2 carbons. Remember that 2 only counts for the O. 6 hydrogens, 2, so I'm going to put a 3. 2 carbons, 2 carbons. I know it's annoying, but I think going over and over it, each time you add a number really helps out. So 2 carbons, 2 carbons. 6 hydrogens, 6 hydrogens. 2 O's, but now I got 4 O's and 3 O's. So here, 2 times that, 4. 3 times 1, 3. It's going to give me 7 O's. I got to get 7 O's on this side. So how am I going to make this number 7? Well, I have 2. 2 times what is 7? Well, 2 times 7 divided by 2 is 7. And now it's balanced, technically, but I never want a fraction in here. So I'm going to multiply everything by 2. That by 2, that'll cancel. That will become 4, and that will become 6. So anytime you have an odd number, you can actually create a coefficient that is a decimal, or in this case, a fraction. And to get rid of it, you'd multiply everything by, in this case, 2, because you had 3.5, and 3.5 times 2 equals 7. 3.5, again, is the same thing as 7 over 2.